In this challenge, you'll be using my SQL workbench to verify that the changes you make in Java get persisted correctly. There is one change you'll probably need to make though to the settings in my SQL workbench to do this. My SQL workbench has something called connection caching. This means data is cached and not refreshed immediately from persisted data. I'll show you how to configure it to make the refresh interval much shorter. This lets you see the changes made in your app reflected immediately in MySQL Workbench. Open MySQL Workbench to your development session. Click on Edit, then Preferences. This will bring up a dialog. Select SQL Editor on the left pane. In the right panel, there's a section called MySQL Session with 3 entries. The second one is the read timeout interval and the one you want to change. Set this to 1 second. Click OK, and now, as you're working on this challenge, you can jump over to SQL Workbench to test your results. For your first JDBC challenge, I want you to write the Java code that inserts an order and at least 2 order details into your database. This should be done in a transaction. Use MySQL Workbench to confirm your inserts worked. Write code that deletes an order and its order details. Again, use MySQL Workbench to confirm your order and its line items were actually deleted. I've included the date-time format that MySQL expects this field to be in. OK, so go give that a try. Pause the video here and go away and work on that challenge and see how you do. When you're done or you get stuck, come back and we'll walk through my solution together. Welcome back. So how did you do? Were you able to change the code to insert the order and order details in a single transaction? Did you add some data in both tables and then delete that data? OK, so let's get started. Here I'm back in MySQL Workbench. Here I can see the storefront schema. I'll leave the workbench open, coming back to it to verify the data as I run my code in Java. I'll get back to IntelliJ. I've got the JDBC Challenges project open where we left off in the last video. I'll create a new method called addOrder. I'll make this private, static, and it returns an int, which will be the auto increment ID I get back from MySQL. This method will take a connection and a string array, which will be the item descriptions of the order details. I'll start by declaring an order ID variable and initialize that to -1. I'll set up my insert SQL statement, which is insert into storefront.order, followed by a list of column names in parens. In this case, I only need order date. After that, we specify values and another set of parentheses. I'll surround my format string specifier with single quotes. The insert for the storefront.order_details starts out similarly, so insert into storefront.order details in this case. I'll define 2 columns, order_ID, an item description, and 2 specifiers in this string, an integer and a string. For the string, I'll use quote literal in my code that formats it, so I'll leave out the single quotes here. I'll be returning order ID from this method. Next, I want to get the order date. I'll start with a datetime formatter object. I can create a pattern and I'll use the one I showed you on the challenge slide. I'll get the current date and time using local datetime.now, and I'll chain the format method to that, passing it my datetime formatter variable. I'll print that out. I'll use this string to populate the insert order statement. I'll print that out too. Now, I could have used datetime specifiers in my formatted string as an alternative to using the datetime formatter. In fact, let me just review what that would look like. The insert starts out the same way, but the specifiers are a lot more cryptic. The $1 sign in both cases means I can just pass a single datetime variable for both of these values. The TF will print the date in the format YYYY-MM-DD. In the second specifier, lowercase t, uppercase T, is the key to the time being printed in the format we want. I'll print this out using local datetime now as the argument. So this is an alternative. I'll run this code since nothing will get inserted yet, so you can see what this output looks like right now. I'll jump back up to the main method and make a call to my new addOrder method. I'll pass that the connection and an array of strings, and I'll just use clothing in my storefront order, so my items are shoes, shirt, and socks. I'll assign the ID I get back to the new order variable, and I'll print the new order ID out. I'll run this. You can see the formatted date using datetime formatter, which gave us a string. I used that string as an argument to the %s specifier in my first insert order string. In the second example, I used datetime specifiers instead, or %t, and you can see both give me the same result. Now let's actually use this insert method. I'll get back to the addOrder method and set up my try with resources block. I'll wrap a new statement in this try. Since we need a transaction, I'll set autocommit to false. I'll set up a variable, inserts, then call execute update, passing that my formatted string, and since I want the generated key back, I can pass statement.return generated keys as the second argument. I'll call commit after this, and then set autocommit to true. In the catch clause, if I get an exception, I want to roll the transaction back. Then I'll throw a runtime exception. Notice that I've got an error on rollback, and that's because that throws an SQL exception too, and I need to handle it. I'll hover over that and select Add Exception to Method Signature. I'm not done yet because I still have to insert the order detail records. If I get a 1 back from inserting the order, I know my order was added successfully, and only in this case do I want to proceed. So next, I need to get the generated key back from the insert order statement, and don't forget that's retrieved by calling getGenerated_keys. That returns a result set. The first record in that result set should have the key I want. The key will be at index 1. I'll set up another local variable, count, which I use to test how many detail items get inserted. I'll loop through the items passed to this method. I'll format my string using the order ID as the first argument. Here, I'll inquote the item string using statement.inquoteLiteral. I'll call statement.executeUpdate with this formatted string, returning the result back to my inserts variable. I'll add the value it inserts to my count variable. If we get an exception saving the records, the data will be rolled back and a runtime exception thrown. But some database problems are silent, meaning we may not get an exception, but something may not go as we expected because of problems with the logic in our queries. I'll add an additional test in this code to make sure the results are what I expected them to be. I'll check if the value in count or the records inserted is the same as the number of items passed to this method. If it's not, I'll set order ID back to -1, and I'll print out the issue. I'll roll back the transaction if this happens. I'll wrap an else statement around the commit statement. Okay, time to test this out, so I'll run this code. I see the 2 insert strings again, but now I see new order equals 1. That's a good sign. I'll open up MySQL Workbench. I'll click on the order table and select the grid or spreadsheet-like icon. This will open an SQL editor pane showing an executed select statement with the result grid below, so you should see order 1 with the order date listed there. I'll do the same for order details, clicking the table-like icon there. Here I can see all 3 of the order details listed associated with order 1, so that's it. Hopefully, you were able to do that and you figured out how to persist some data of your own. The second part of the challenge was to delete an order, which includes its line items. Getting back to IntelliJ and the JDBC Challenges project, I'll add a new method to do this, and I'll insert this method after the addOrder method. This will be private, static, void, and called deleteOrder. It will take a connection and the order ID of the order to be deleted. I'll start with a formatted string, so delete from storefront.order where order ID equals %D. I'll format that using the order ID. I'll get a new statement in a try with resources block. I'll set up a variable called delete records and assign that the value of execute update. I'll pass that my delete query string. I'll print how many records got deleted. That should be one in every case. If I get an exception, I'll throw a runtime exception. Getting back to the main method, I'll comment out the add order code and the println below that. I'll make a call to the delete method before that code. I want to delete order ID 1 in this case. I'll run this code. The output says one record was deleted. I'll verify the results in MySQL Workbench by re-executing the select statements. First on order, and the result, grid has no data. I'll do the same on order details. You can see I no longer have either the order or the order detail records. Because of the cascade delete, defined in the order detail table, I didn't actually have to include the delete order details code in Java. This was optional for this scenario. Maybe you did code this and included it in a transaction. This is a valid solution as well. I'll change my code a little to do it that way. First, I'll uncomment the code that creates a new order and rerun my code so I have an order to delete. This will set up order number 2, as you can see. I'll change the number from 1 to 2 in the delete order. Next, I'll start by adding the transaction code to my delete method. So first, I'll set auto commit to false. I'll call commit as the last statement in the try block. I'll execute a rollback if I get an exception. I'll again overhover the error I get on rollback and select to have the SQL exception added to the method's throw clause. I'll add a finally clause in this case because I'm throwing an exception in the catch clause. In either case, I want to set auto commit back to true. Putting that in a finally clause ensures it always happens. Now, I'm going to make the delete order string more generic and put a placeholder in for the table name. I'll change the name of the variable delete query to parent query. Then I'll pass the table name storefront.order as the first argument here. Next, I'll create a child query using the same formatable string, this time passing the order details table, and I'll still delete by order ID. Remember, the child table has this ID in it as a foreign key. I'll change the name of the query in the execute update to be child query. I'll change my print statement to say how many child records were printed. Now, I just need to add the code to delete the parent record. I'll execute update on the parent query and return results to the same variable, delete records. Again, it's possible something could go amiss and not throw an exception, so I want to confirm one and only one order is deleted in this case. I'll print that my order was successfully deleted. I'll include an else statement and roll back if my result wasn't 1. I probably should have a statement printed here too, but you get the gist. Before I run this, I'll comment out the code that adds a new order. Okay, I'll run this. I'll see that 3 child records were deleted and then order 2 was successfully deleted. I'll pop back over to MySQL Workbench and re-execute the queries that were generated when I displayed the table results. These are currently showing us no data from last time. Remember, we have created records again and deleted them before coming back here. I'll start with order and running that select again. In the result grid below, I should have no data again, so I know this code worked. I'll do the same for order underscore details, opening that tab and executing that select query again. Then I get no data, so that's good. So should you manually delete child records in your Java code or depend on cascade deletion? The answer to that question is, as usual, it depends. if you're trying to be database agnostic, meaning your application is going to be deployed in many environments with different databases. In this scenario, you'll probably be working with varying degrees of database support, so then maybe you'd manually code the delete child records, and you'd have confidence your code is always cleaning up the child records, regardless of how the database is configured. Doing this might be simpler than having to publish requirements on how the database needs to be set up with Cascade Deletes implemented. If you're deleting a large amount of data, it's probably more efficient to take advantage of the table's Cascade Deletes done on the database server's implementation. All the major RDBMS vendors support Cascade Deletes, so that's a positive, but there may be some vendors or lightweight RDBMSs that don't. Also, don't forget your JDBC backend could even be files like CSV or JSON files, so in that case, you'd want to implement the delete order_detail functionality yourself. In the delete order detail code, you can see I parameterized the SQL statement with the item description. Ultimately though, I passed a static string to the execute update method. In the next video, I'll show you an alternative for parameterized SQL in the form of a prepared statement.